CDW, now he's at AT&T, is that what I heard you say? Okay, Jim's gonna tell us all we need to know about IPv6. Take it away, Jim.
Thank you. All right, so I was here a year ago, and I would call it an overview of IPv6 in terms of what's going on and some of the basics. So when I was putting this together for tonight, it's kind of an interesting challenge in terms of what do you talk about for 90 minutes plus. Because I mean, imagine this. So imagine that somebody from outside technology walks up to you and says, okay, I got 90 minutes, why don't you teach me about TCP/IP? You know what I mean? Where do you start, right? So I try to take the view of building a lab and then kind of talking about some of the pieces. When I listen to a lot of presentations about IPv6, and there's a lot of things that are not well understood, or people are like, man, this is why did they do this? Because it was the protocol's actually it's almost 20 years old. So some of it's kind of lost to history. So I'll try to explain why they did a certain thing or what the thinking was. At least hopefully that helps things make sense. All right, so feel free to ask questions, and try and take them on unless we get short on time. So one thing I didn't want to talk about, and this always happens when I talk about IPv6, that I'll talk a little bit about the why, because I think it's important. In a sense, it's kind of like power. It's one of those things that you don't notice unless it's gone. I mean, you just kind of take it for granted, but if you lose it, it's really annoying. So, but I always get the question when I talk about IPv6. Somebody will be like, okay, I understand how to use it and all this stuff, but why? What does it give me? Right? I always get that question. So I try to think, okay, what is one thing that I can talk about that that will resonate with everybody? Something that you can really see that, okay, this is a concrete benefit that we don't have today. And you can kind of see for other types of technologies how this would help. And probably the best example is gaming. So in terms of gaming, if I look at a lot of the new games, they're very interactive. So I tend to have a lot of people playing online games, doing video conferencing, doing multiplayer interaction. And that means that all of those people have to talk to each other over a network. And that creates a lot of interesting challenges that we're going to talk about some of them with the current IPv4. And so if you look at Microsoft, one of their product managers actually says that for Xbox, if you want the optimal experience, you should use IPv6. They've actually tested it, and you will get the best performance using that protocol. Because there's a lot of limitations with IPv4, not that it's a bad protocol, but just because of the scale of the internet, it hasn't kept up, and it's causing a lot of complications. And so it really starts with NAT. So if you look at IPv4, it only has a theoretical limit of 4 billion addresses. And in a world of 7 billion people with even more billions of machines, it's pretty readily apparent that that's not enough. So that's been apparent for a long time, so we came up with NAT. The idea of NAT is it's like a PBX. I extend it, I share addresses, kind of like multiplexing. So basically make those 4 billion addresses service a much larger array of people and machines. However, there are some challenges with that. If I want to talk to you and you're using NAT, now I need to use some kind of a lookup service or a special method or some way to figure out where you're at, right? Because you're no longer directly reachable. You're going through a gateway. So we usually use something like Stun or ICE or some other method where people can use a third-party service on the internet, and that allows them to locate each other. So then they can talk directly back and forth. Now, this has worked fairly well up until maybe the last 3 or 4 years, and now this is starting to break down because IPv4 is so overstretched that now one layer of NAT is no longer sufficient. So now we have to have multiple layers of NAT. Because again, we're so overstretched that just to keep the internet working, this is necessary. So now we have what's called CGN, which is multiple layers of NAT. And the problem with CGN is it basically makes direct communication almost impossible. So a good example that I've heard of this is somebody will go out and they'll get a home security system. And they have a video camera that they put at home. And that video camera registers with the website and then they can watch it over the internet. Well, unfortunately that will not work with CGN. And then there's a lot of things like that. If you go through 2 layers of NAT, it breaks that. So there's a lot of challenges with that. And CGN is actually becoming quite prevalent. So if you have UVerse, you probably have CGN. So if you have AT&T or if you have Verizon, most likely you are behind multiple layers of NAT. So
I've got UVerse and I've got an external IP that has been the same for like
there are some exceptions. So if you had it for a long time, but I can tell you not just with residential. So even with some of the business customers I've rolled out, AT&T has said we will not give you a public address. You will use a private address, and we said, okay, thank you very much. We're going to go with a different carrier.
Oh, really?
And
So
they said, okay, sorry, we can't help you.
just up until recently, I had a external, IPv4 address, and
It depends on the area, but I have actually had AT&T say, I understand you're going to go with a different carrier, but we cannot give you a public address.
wow.
For this particular, I don't know if that's a CO issue, but I have personally run into that.
Well, so do they have IPv6 yet?
Yeah.
Yes and no. They have a form of it called 6RD. I don't think we'll get that tonight. They don't have it directly like Comcast, but they're working on it. And as far as speaking for AT&T, so I'm speaking as an individual. As far as speaking for the company, I mean, I just joined AT&T like a week ago, so.
So it's not all your fault, yeah.
Yeah, you can blame me in a couple of weeks, but not yet.
they hired you to get IPv6 rolling.
That's it.
For other companies.
Yeah.
So I've got a still tunnel then is what we're talking about, right?
Yeah, with AT&T you do 6RD, which is like a tunnel. So you can't. You're right. You can get it with some locations, but with some you can. And Verizon is similar. So, and this is going to get worse just because there's just not enough addresses, right? And we got to. If somebody calls up a carrier and says, I want to get on the internet, the carrier's not going to say, oh, sorry, I can't help you. Go somewhere else, right? So the way we're making that work now is we have to have multiple layers of that to stretch it out. So this causes some really interesting problems with gaming. And typically what we have to do is now we have to go through a relay. So here's the challenge of this, is if I have to go through a relay, let's say I am a gaming company. That means that now in order for people to use my service, I have to set up some kind of a service that they can relay through. And that service has to match the bandwidth of all my users. So all my users that have fiber to the home, that have 100 megabit internet connections, if I have thousands of those, I got to be able to service all of them through that relay, because a lot of them are going through multiple layers of NAT. So you see how that can get kind of expensive? So this is kind of the hidden problem of IPv4, is everybody thinks like, it's not my problem, somebody else is going to deal with it. But the challenge is that there's a cost, right? Because in order to maintain all this infrastructure, and here's the other big challenge. If I'm a carrier and I have to deploy CGN to service new customers, how much money am I making on deploying CGN? Yeah, nothing. What does CGN do to my support and operational costs?
It complicates it.
Does it lower them?
Yeah.
Sure.
No, it actually has a substantial increase. So the hidden cost of IPv4 is all of this. This is going to cause pressure in terms of margins and prices to go up, because to support all this infrastructure, somebody's got to pay for it. All right, so the advantage of IPv6 is, because it has, for all practical purposes, I don't harp on this a lot in this presentation because, like I said, there's only so much we can fit in. but really for all practical purposes, IPv6 is an infinite address space. So if you listen to some of the people who do this at the carrier level, who basically deploy it all over the world, IPv6, it's so unimaginably big that what everybody thinks is the technology will become obsolete before we run out of addresses. Right, so look at it another way. If you look at IPv4, it came out in the 60s, right? And maybe it will last another 10 or 15 years. So that's what, maybe a 50-year lifespan? So how many people think that IPv6 is gonna last, a lot more than 50 years? I don't know about that. I mean, because if you look at how fast technology is changing, are you sure that's gonna cut it forever? So I mean, it's designed to last for 100 years, but I don't think we'll make it that long. And kind of the consensus is by the time we get to the point where, we have interplanetary travel or something like that and you need more addresses, there's gonna be other technologies, right? Because it's just not gonna work. So if I look at this guy, because I have unlimited addresses, I don't have to use NAT. I mean, that's not the only reason. So the advantage of that is, if I wanna look somebody up, all I have to do is DNS, right? And even if I have to use dynamic DNS, if I have a dynamic address and it's constantly changing, there's lots of free services. So the cool thing about using DNS is it's already out there. So if I'm a gaming company, I don't have to basically build out infrastructure. Everything I need is there. I just have to write the game and it just works. Whereas if I'm using IPv4, now I have to maintain all this stuff. So it's not, with IPv6, I wish I could think of something sexy. I mean, it's not like a cool new toy that's flashy, but the reason we need it is just for practical reasons. The burdens that we have to bear for IPv4 to make things work are starting to become somewhat prohibitive. All right, so I always like to just kind of briefly mention this. I don't think, in my opinion, I think we're kind of past depletion. Just because if you look at the growth, I don't think this is so important anymore. Right now, so in terms of like the free pool for IPv4 is depleted a long time ago. If we look at the 5 regions in the world, Asia and Europe are out, right? They've been out for a while. The US will probably make it about another year. It's hard to say exactly. What does that really mean? I honestly don't think it means anything. But this is usually a popular question, so I like to at least throw it out there. But one thing I can tell you that's interesting, if you look at ARIN, so ARIN is who hands out public IPv4 addresses for the US and Canada. They have less than 25 million addresses remaining. And if you look at the last couple of years, we've been averaging about 40 million addresses a year. Now, I mean, obviously we're not gonna average 40 million addresses anymore because we don't have it, right? So that's slowing down because all the major carriers are deploying CGN to basically try and slow that growth and give themselves time to deploy IPv6. So, more interesting though, because this is the real question I get, especially the US, is people say, yeah, the US is a mature market, we don't have a huge, we have population growth, but not a huge population growth. We don't have a huge increase in computer penetration. So in the US, this isn't our problem, right? It doesn't affect us. Well, not really, because even though we don't have the population issue, because our population has fairly high penetration, mobile devices are huge, right? So even look at all the people in this room are totally guilty. How many people only have 3 devices? Not even one, right? So one of, it was the Yankee Group estimated, this might be a little high, but they estimated by 2015 that the average person will have 10 network devices on it. Because you have glasses, right? Your glasses have sensors now, like glass, that's becoming really popular. Clothing, all your clothing has RFID. Like I can tell you, my older son plays hockey. If you have a kid in sports, it drives you nuts, right? So the equipment's expensive. It doesn't matter what the sport is, hockey, football, dancing, I mean, it's all expensive. So you buy all this nice equipment for your kid, and you would think when they go into the locker room to to change, they're all careful with it, right? Yeah, not. So this is the future is going to be that we have RFID tags that we put in all the equipment. So your son or daughter brings their equipment out, and you can literally take out your smartphone and scan it, and it will say check or not, right? Check, all the relevant RFID tags are there, or no, they're not. That's where we're going, right? So everything is going to be online, right? That's called the Internet of Things. So we have all these mobile devices, we have the Internet of Things, and the Internet of Things, that's scratching the surface, right? What about the light bulbs? All light bulbs are starting to come online, right? So when I look in a building, I can tell you which light bulbs are burned out, I can tell you how much power they use, I can tell you when they go on and off if they have sensors. Everything that has power is basically going to come online and into an intelligent sensor network. So that's happening now. There's already a lot of companies that have been doing that for years.
Well, I
So you
saw,
have-
I was just trying to jump
Sure.
in, so there's also like, they're addressable. You can make them change like the color settings and, blue, red, green, and,
Yep. And it makes sense, right? It's a logical progression. We want to be able to manage and control and monitor all these things. But if you look at that, right, the current estimate is by 2020, we're going to have 50 billion things on the network. So 50 billion things, and we have an addressing system designed for 4 billion, right? So that, and in the US is actually a leader. Silicon Valley is the center of all this, right? So this is very much in the US. So all of this stuff is putting pressure on IPv4. That's why it's an issue. All right, and the other thing I like to show, I really think we're past depletion, and now we're looking at adoption. So if I look at adoption, it's actually picking up quite a bit. And this year we will actually hit critical mass in the US. Several other countries like Sweden have already hit it. But that's when because that's the next big question I get is like, okay, I can see like with gaming, with telephony, with unified communications, I can see how that makes life better. So when are we going to see the killer app? Well, I actually expect to start seeing things in fourth quarter this year because we'll cross 10% by the fourth quarter. So if we look at some of the major carriers, we're doing pretty good. Virginia Tech is probably one of the leading universities, but if you look at most of the major universities, more than half their traffic is IPv6, which means that all of my students that are coming out of all of our major universities, including U of M and MSU, they're basically used to using IPv6, right? So all of these people are coming into our workforce with the expectation of, what? You don't already have it rolled out? I mean, come on. You've been using this in my college, I've been using this in school for 5 years, what are you guys doing? Right, so this is kind of becoming the expectation. You look at the DoD, they've been running for over 10 years. Verizon Wireless, so largest cellular carrier, 40% of their traffic is IPv6. So that's pretty significant deployment. Comcast is the largest ISP for residential, they're over 20%. AT&T, they're the largest carrier in the world, they're almost at 15%. And then T-Mobile has an interesting statistic in that if you look at the new T-Mobile handsets, they're actually IPv6 only. So that's an interesting challenge too. So now if I have people on my network with T-Mobile devices, how do they interact with my applications if they're IPv6 only? That can create some interesting challenges too. In the US, it kind of fluctuates, but we're roughly around 6%. So 6% penetration, I mean, it's not huge, but I definitely wouldn't call that insignificant. So if I look across the US, that's a pretty decent penetration figure. If I look at weighted content, so this is by the Alexa 1000. If I look at the top sites and I look at what people actually go to, about 45% of it's reachable over IPv6. So it's pretty decent progress. All right, and this, I came up with this a couple months ago, so it's a little out of date, but the other question I get, and then we'll move on to actually setting it up, is, yeah, okay, it all sounds good, but when are people actually going to do something? So really, IPv6 is really nothing special. It's just a technology, like anything else. So when I'm looking at any technology, it's all about the adoption life cycle, right? Am I a bleeding edge innovator, or am I one of the people that you have to drag me screaming, right? And we're all different depending on the area. So this is, if I look at the 50% mark, this is what we're looking. And this is based on what Google's seeing, so I think this should be pretty close. So you can see we're gonna cross 10% in quarter 4, and we'll hit 50% towards mid to end of 2016. So I mean, that's still a little ways off, but I know there's a lot of people that think, you know, it's not gonna happen. They're gonna be mighty surprised in a couple of years. So we're moving along pretty well. And in terms of companies run the gamut. I mean, I can tell you from dealing with this. So there's a lot of companies that are like, you know, I'm not gonna do it, nobody's gonna make me, and you know what? I have a great story. So I can think of somebody in my family. They had a flip phone. They loved their flip phone. They hate smartphones. Those smartphones are, I hate those things. You know what? They went to renew their phone, and carrier said to them, I'm very sorry, but if you wanna stay with us, you have to get a smartphone. I'm not going to stay with you. Went to another carrier, same thing. Went to another carrier, same thing. You know, you cannot have a cell phone. So, you know, were they happy about it? No. You know, but guess what? Now they have a smartphone because all the carriers say you have to have one. So, you know, there are going to be some people, I expect, that are probably going to wait, 2017, 2018 until they absolutely have to. When basically the major carriers are saying, okay, we're not going to route IPv4 on the internet anymore, and you have to buy a special service from us, they'll be like, fine. So there's going to be people like that, but there's also a lot of people, I can tell you, when I do at work, that are working on it right now. So I mean, it's really looking at this and figuring out, what makes sense for you, and when you look at it as a technology, where do you want to be on the adoption life cycle? All right. So any questions on that? I mean, I don't want to spend too much time, but I'd like to at least give an overview, yes.
So, you were saying something about you could be using this and it will slow down your connection if you have a faster connection. So I've got a place down in Austin where... Okay, so you're playing a game and somehow it goes based on the CG, what is it, CGN? You're using that, it makes the game playing slower?
So the challenge with CGN, so CGN is just multiple layers of net. And I mean, unless you have an underpowered device, that in and of itself usually isn't going to slow you down. The problem is, if I'm playing, let's look at video conferencing, that's probably the easiest to understand. If I'm doing a video conference with somebody, right, at some point, I have to stream the video into their house. So if they're behind multiple layers of NAT, then it might be impossible to do something directly, which means that that person has to go to a third-party service and pull the video, as opposed to me sending it, right? They have to go through a relay point.
Okay, all right, so
the
there's
problem
delays.
the problem with the relay point is that has a limited amount of bandwidth, right? So look at it like this, because this is a common issue with companies. If I'm a company and I have people working from home, a lot of times from a security point of view, I don't want to do what's called a split tunnel. I want all their traffic to come back through me so I can control it, right? Sounds good. The problem with that is, nowadays, a slow connection is 10 megabits. So if I have 1,000 user workforce and half of them are working from home, I mean, the amount of bandwidth I have to support that is prohibitively expensive, and most companies can't afford it.
Okay, so
So it's the same thing with the relay, right? If I have to relay all that traffic through one central point, it becomes prohibitively expensive, and usually what happens is it's oversubscribed and you get poor performance.
Okay, so I have an
I mean,
option.
does that answer your question?
Okay, so let me a little bit more specific. So I have a place down in Austin, and they're doing this gigabyte rollout. For $70 a month, you can get a gigabyte connection. But what I'm hearing you say is...
For a consumer though, right?
Yes, this is, fiber in the house,
Yeah,
right?
fiber
So we have
in the
fiber
home.
in the house, I'm just gonna flip it up. So if I'm playing a game there, I might not get the full use of that connection because...
So gigabit as a consumer can be relatively cheap, right? But if you're a business where you're serving tons of data, because even when you have fiber to the home, there's still a cap, right? If you start serving ISOs from your house, so people are downloading ISOs 24/7, your provider's gonna call you up and be like, you're not doing that for $70 a month, right? They might not spell that out for you, but they will not allow that, right? If you're a business though, you do have the expectation that I can do whatever I want, but the connection costs a lot more. So the problem is, if I have 100 users, like you said, and those 100 users each have a gigabit to their house, and now some of those people are behind multiple layers of NAT, they have to come through me. So what do I have to have, a terabit connection to support them?
Okay.
So how am I gonna pay for that? Because you're right, because that's exactly the problem. If I'm a consumer, I can get massive amounts of bandwidth for super cheap. But if I'm the business that has to aggregate all that bandwidth into one central place, that gets really expensive.
Right,
So that's
so like
the
you said, they
challenge.
oversubscribe that business connection.
Yep,
So the gamers suffer because they're not getting the full throughput that they think they should get.
yep.
Because they had a gigabit connection. They're never gonna see the gigabit speeds because it's going through that relay.
Yeah, so that's the problem with current infrastructure. Okay, so, when I did this, I tried to think of, if somebody came to me and said, you know, okay, I'm a Linux guy and I wanna start working on IPv6. You know, this is a really basic setup. So I did all this in ESX, which anybody can get for free, and, basically I have a vSwitch and I have 3 VMs. So all of these guys are running Ubuntu 12.04, which is a fairly popular distro. The reason I went with 12.04 is because it's the long-term version. I don't like upgrading, you know, every couple months, or because I think the latest is 13.10 or something like that. So this is really basic, but you can still learn a fair amount from it. So client server, I mean, that's pretty obvious what you're going to do there. And then this guy's also a server, but I'm using him as a gateway, firewall, NAT, DNS, DHCP, proxy, and server load balancing. So I mean, this is just to give you an idea of, you know, if I have a business, these are the kinds of things that I might want to start looking at. You know, how does that work? How am I going to run it? Because really, even doing this at a large scale, the concepts are still the same. Okay, and then using that setup, I have a couple of example topologies. So one is a really simple one. If I look at this guy on the left, this guy at the left, I'd have a very simple setup where these two guys are on the same VLAN, they can directly communicate, and then this guy would be DNS, DHCP outside world. And then if I look at this guy on the right, it's a little hard to see, but there's different colors, those are supposed to be different VLANs. So in other words, this guy on the right, if the client wants to get to the server, the client has to go through the firewall. So this is interesting because now I can play around with things like NAT, proxying, server load balancing. Like for example, let's say the client is IPv4 only and the server is IPv6 only. So how am I gonna make that work? Am I gonna do protocol translation? Am I gonna proxy it? Am I gonna do a reverse proxy? Am I gonna do server load balancing? So I mean, you know, at home, you know, you probably wouldn't run into that. But let's say I'm a business, right? Let's say I'm a business like GM, and I have, you know, tens of thousands of servers. Well, for me to actually go deploy IPv6 or make changes on all those is pretty expensive. So maybe I'm not going to. You know, maybe I'm going to use a server load balancer or a proxy or something else. So the bigger the scale gets, you start looking at, you know, how am I going to roll this out? So I'd say with IPv6. It's not that complicated by itself. The biggest challenge is if I'm looking at rolling it out to a large company, how do I do that in a non-disruptive fashion, right? Because if I start rolling something out and I screw up my network access, I'm gonna make a lot of enemies really fast, right? Because it's just like the power. If I take somebody's network connectivity away, they're very unhappy. I think is that the voice? What happens when someone loses their network connectivity?
Or get throttled back.
All right, so what I tried to do is when I set up Ubuntu, I didn't do all the faults because, you know, obviously I selected some packages, but I tried to stick to a fairly vanilla installation and then document, okay, here's what I had to do, or if I had to actually get some software or configure something. So hopefully with a lot of this, if you wanted to replicate it, you could. I didn't do anything with the GUI just because the challenge with Linux and GUIs is there's a lot of different distros, and every distro has their own tools, has their own philosophy. So I try to stick more command line that's more, there's still some differences, like between Red Hat and Debian-based distros, but at least you have an idea. I made all of this Linux specific, but it's similar in Windows and OS 10. So if you deal with those two, it should at least give you an idea. So when I start up a system, and I don't do anything with IPv6, right? So all modern operating systems have had IPv6 on by